So I think it's a lot easier to be able to just see it on the whiteboard, and I think it would have been easier if they would have put that as well. So I'm going to do my best to explain this. Please try to excuse my poor drawing and my poor penmanship and everything like that. I left off the relationships that we don't need for this example. I left out contrariety, super implication. It looks like actually that's all that I left out. And I left out this side because we're just going to talk about the example they give, starting with some students are not intelligent. So if we say that some students are not intelligent, which is our O-type statement, we're assuming that's false. And keep in mind again here that we're trying to say that O and I can't be false at the same time. So if we assume that O is false, then that makes A true by the relationship of contradiction. It basically says that the opposite of this has to be true if this is false. So all that means is if O is false, A is true. And if A is true, all students are intelligent, then it must be true, I, that some students are intelligent. And that's a little bit more obvious. We say, okay, if all students are intelligent, then obviously some of them must be intelligent, which means that this is true as well. So as you can see here, our original question was whether O and I can be false at the same time. And as you can see, if we work this out on the square of opposition, when we assume that O is false, it makes it so that I is true. And it works the exact opposite way. So again, I think they could have explained this a little bit easier because all this means is that there's an inverse relationship. If O is false, then I has to be true because of the relationship of contradiction, which leads to the relationship of subimplication. That's basically it. There's an inverse relationship. If O is false, then I must be true. It works the other way too. If I is false, then O would have to be true. I hope that's helpful, and have a great time continuing to try to figure out the beauty of logic.